Hi, good morning. It's Jim from the mavestar Observatory. We're going to do an overview of all the things we cover on our dedicated website. If you want to go over there and have a look at some of the things we've got on there, you're welcome to. poleshiftnews.com is what you need to type in. Before we get into this overview, big thanks to the people that have been supporting us over the last couple of days. We need the support. We can't do it without you guys. It's a publicly funded observatory, and you know why that is. Simply, if we're paid by organisations, it ain't going to be long before they limit what we can talk about and what we can do. So let's get into it. So our main objection is following the magnetic pole migration over the northern hemisphere. We've been doing that now for a couple of years. As you can see, the last entry was the 11th of the 9th. We're shortly about to put a new data set up there so that you can see what's been happening recently. The reason why there's around about 4 weeks of data missing is because we recently had some work done here at the property where the Trimag system's situated, and it would have interfered with the equipment, so we shut it down for a month, but we've re-established it around about 3.5 weeks ago. So on the 17th of this month, as usual, we'll be putting the data up. But as you guys know, we're slowly getting a migration still towards Siberia at around about 3.9 miles per month on average. So the pole's still migrating. It's still making its way to that 40-degree mark where, in theoretical terms, we should enter the weak field lines. And if you remember some of them experiments which we conducted, when the poles enter weak field lines, they begin to flip at that point. And I've put that off around about 4 to 7 years. And I've based that on the shrinkage of the Canadian high intensity, which has reduced by 50% over the last 7 years. So I believe in the next 4 to 7 years we're really going to start seeing some activity over the northern hemisphere. Let's have a look at the magnetosphere data over recent times. So as you guys know, we've been covering the magnetosphere strength now for a little over 12 months or thereabouts, and there hasn't been any noticeable amount in reduction of the magnetosphere strength over that period of time. But that doesn't mean, in around about 4 years' time, when we start to get to those weak field lines, that won't be the case, because I expect that at that time, the magnetosphere is going to drop dramatically, and we've got the equipment in place that will show that taking place at that time. So although there's nothing majorly changed with the magnetosphere at this current point in time, it doesn't mean to say that that's always going to remain the case. Moving on to our magnetometers that are spread out around the world. If you click on the actual chart on the mavestar global data page, it will take you straight to the Gold Coast. You'll be able to have a look at all the data that we've collected from the Gold Coast, Perth, Australia, Kentucky and Southern California, and of course Hong Kong. Tony from Hong Kong just recently sent us a data drop which has now been added to the website. If you just click on the chart under Hong Kong, it will take you to all the data that Tony sent us, and there has been just a marginal decrease in the intensity strength over there in Hong Kong recently, but time will tell. It's still early days. We've been collecting data now for around about 6 months from these. We've had a couple of teething problems with some of the stations, which we've now put right. We had one in Perth which seemed to be malfunctioning from day one, which we sent a new one out now to replace that, and the data that's coming from there seems to be okay, just as the others are showing that little deviation as the month goes by. Same with the Gold Coast. We've recently, over the last week, had some data sent in from the Gold Coast, Australia there, from Richard, and as the data comes in, it gets uploaded within, or should I say, processed within a day or two, and then uploaded straight onto the website. So it's worth, if you're interested in the data from these high intensity regions around the world, what we're doing is we've put them in the paths of the merging intensities. Like say over Australia, we know it's moving up towards the equatorial region, so we've put them just in front of the high intensity region, so that we know if it starts to creep up on our charts, we know that we're going to get an indication that that intensity is still moving up towards the equatorial region. So yeah, it's worth keeping a look on these guys, because you know, as the data comes in, it gets processed and put up on the website, and if you want to follow it, it's on the website. You can do it at your own pace and time. Now guys, as you know, we've got a Muon detector now, fully functioning and working. Over an hour on average, over the last few days, it has detected around about 492 muons per hour per square metre, which is slightly less from the last time we took a reading. It's about 50 muons less per square metre per hour than the other day when we took a reading. Soon there's going to be a web page on our website dedicated to all the information that we gather with regards to muons, not just here in the UK where our first detector's up and running, but when we start getting them out in the field around the world. All the data that gets collected is going to go up on a single page, and you'll be able to click on England. It's a bit like you know, our magnetometers that are out around the world. You know, you'll be able to click on the location to find out how many muons are inbound in that region, and it's going to be great to find out when we get one in Brazil and compare it with somewhere like South Australia, because we've got the two ends of the spectrum. One's going to be hopefully showing us more muons inbound in the weaker regions of the South Atlantic anomaly in Brazil somewhere, and then we're going to have less muons, I believe, in the south of Australia where the highest intensity of magnetism is. I'm believing that there'll be more protection in the highest intensities than there will in the low, and you know, the only way we're going to find out is by getting that equipment out early January, along with Geiger counters and magnetometers. There's quite a bit of kit going out to these locations, so you know, there's a lot of work to do, guys, in doing that. I'll just tell you what the background radiation was on a test that I did with the Geiger counter this morning here in the UK. We're looking at 00.16 microsieverts, so it's not a lot of radiation really. When you're worrying about radiation levels, they want to be over 0.5 or half a millisievert, so you know, we're still well below background radiation levels increasing, but we do know that cosmic radiation has increased fourfold, and that's why we're getting the quantity of muons per square metre as what we are right now. Now, with regards to oxygen levels in the atmosphere, they should be around about 20%. As you can see here, it's 20.9% they reckon, but when we did atmospheric oxygen test at the beginning of this year, and if you remember, the results were, you know, surprising, because it showed there was less than 20% atmospheric oxygen in the test results. We repeated it about 4 times and left it even longer for the wire wall in the test tube with the little hole in the bottom to allow the water to rise as the oxygen was being consumed by oxidized wire wall. We repeated the experiment, and you know, we still found that there was less than 20%. So I think it's worth doing another test to see how much oxygen is in the atmosphere right now and whether that's a concern. It's a simple experiment. You guys can follow me. We'll try and get it squoze in over the next week or so. All you need is you know, a test tube which is graduated, so it shows you you know, the mils along the side, and what we do is we drop a little hole in the bottom so that, you know, when we submerge it into the water, it fills up to a level of 0. We put a little bit of wire wool that's first been soaked in a bit of mild acid, so we use vinegar in this case, and we push it to the top of the test tube, and then we just place it in the water. And what happens is, as the oxidation of the wire wool takes place, it draws the oxygen out of the atmosphere within the test tube, and it draws, as that happens, it creates a vacuum which lifts the water level up, and the amount that's consumed should only be oxygen in the oxidized reaction with the wire wall, and that should give us what level of oxygen was actually in the test tube during that period of time when we took the sample of air. So if you want to follow us and do your own you know, oxygen or atmospheric oxygen test to find out in your location whether it's higher or lower than the suggested 20.9%, which should be in the atmosphere, then you're welcome to follow us along with that experiment over the next week or so, because I think it's a good idea to keep an idea on as much as we can. I mean, it doesn't require a lot of time to do these tests, but it's interesting, you know, we take it for granted. that there is 20% oxygen in the atmosphere, but when you consider how much we're actually burning with regards to how many cars are on the road, how much fossil fuels we're burning, but all these chemical reactions require oxygen, otherwise they don't work. You know, your engine wouldn't work without a quantity of oxygen going in there with the mix of fuel to create that explosion. And let's face it as well, there's also 7 billion human beings which are consuming oxygen at any given point in time on this earth, as well as all the other biodiversities that convert oxygen during respiration. So, you know, I think it's well worth keeping an eye on these things, as well as other things that we do here at the Mavestar Observatory. So that's another thing that we can do over the next week or so. Just taking a quick look at live data regarding sunspots. As you can see, the disk is void of sunspots today. There's no geomagnetic storms. X-rays are low and normal. You know, your KP index is low. Protons are average. X-rays are standard. We know that as there's a low solar output at the moment, cosmic radiation is going to be on the increase. As a result of that, we can see what happens during solar minimums. You know, the cosmic radiation increases, and the weaker the solar cycle, the more the increase of cosmic radiation. So, you know, at the moment, things are quiet with the sun, and continue to be that way. Taking a look at the currently erupting volcanoes around the world, you'll find that there's around about 21 at the moment erupting or in a state of eruption. This is down around about 30% from last year, so there was more activity last year. It was over 30 erupting last year than there is today, so there is around about 30% less volcanoes today in eruption than what there was last year. Quick look at the jet streams, more in particular what's going on over the United States. We can see that the polar jet stream's dipping well below you know, Central America, and if you didn't know already, the lower the jet stream, or the lower the polar jet stream is, anything above that jet stream gets that Arctic blast. And for the foreseeable future, until things change with that jet stream, that's the way it's going to continue for the United States at the moment. But just taking a quick look at the jet streams around the world, you'll see there's a lot of subtropical mixing with polar jet streams. This is a common thing that we've been looking at for some time now, and you know, it's almost indistinguishable which is which over the northern hemisphere. We've got a lot of troughs you know, lurching towards the equatorial region on our planet, and as a result of that, it's going to bring, you know, those cool Arctic temperatures along with it. If we have a look at what's going on over the southern hemisphere, it's the same story. You know, indistinguishable jet streams from subtropical to polar, and it's the same story over the northern hemisphere. And whilst this continues to be the case, it's going to deliver droughts like we're seeing in Australia, Arctic blasts in America, and, you know, over Europe. And, you know, this is going to continue, guys, shutting down agricultural land across our planet. So guys, I'll leave it with this last clip, and we'll talk about that in just a short while. But I just wanted to say, you know, as you can see, we don't just talk about these things. We actually go out there, we build the equipment, we collect the data from all around the world now, and there's more equipment going out early January, so we can get an idea of how much muon radiation is inbound in those two regions that we talked about earlier. But, you know, I've got to say this as well. I don't sell nuclear missile silos that are decommissioned, and I don't sell yachts. And, you know, all I say to you guys is do what you feel you need to. But bear in mind, when you start seeing headlines like this, Europe losing 1,000 farms per day, you've got to ask the question, at what point is this going to affect you? That's 7,000 farms a week going. We know that America's agriculture's taking a big hit with the changing climate. We know that it's affecting a lot of continents around the world, and as a result, you know, if you just compare with commodities, and food is a commodity, when there's less of it, you know, the prices go up. It's just like gold. If there's a lot of gold on the market, it's cheap. If there's less gold on the market, then the prices go up. Food is no different. Labour is no different. It's the same all around. Right now, we're at a point in time where labour's at its lowest because of the surplus amount of people out there looking for work. So wages are low as a result of that. And then we've got food prices increasing as a result of agricultural land going offline. You know, when these farms disappear, there's all that experience gained over those years. A lot of these farms have been passed on from generation to generation. When you lose a farm, it's not something that you can put back online overnight. A lot of people that move into farming that have never done it before have got a lot of lessons to learn about farming before they become profitable. So when we lose experienced farmers, like we are seeing right now, 1,000 farms a day going, it's not easily put back online. And you know, it's just a sign of the times that we're facing up ahead. So you decide what you want to do for your families. You know, I don't sell, like somebody suggested, nuclear missile silos or yachts. I just, you know, put these ideas out there, and I think there's nothing wrong with sharing ideas at this point in time, because, you know, anything is possible. It's not just an economic collapse that we could face. You know, we can also face something that we've got very little control over. You know, what we're seeing now with nature changing the climate of our planet. But I will say this, you know, we've got to have a look back into our history and just remember, you know, when the Vikings left Greenland, it was because it was no longer able to sustain agriculture there. You know, when these cities have been abandoned in our, you know, past history, it's because agriculture was no longer sustainable for those cities. And we live in a time where there's no change. You know, if agricultural production drops, then it's no longer going to be able to sustain the people in the cities that we live right now. If the climate goes back into a glacial period, you know, we also stand the threat of a grid down. If the magnetosphere weakens, you know, again, a moderate solar flare, it doesn't have to be like the Carrington event. During a weakened magnetosphere, just a moderate solar flare could knock out the grid, and we all know what will happen shortly after that. You know, I was speaking to someone the other day with regards to, you know, all that there is out there right now with regards to alternative energy production. You know, we have got 3 or 4 main types of energy that we can all access, as opposed to just relying on the power grids, because we know that the power stations are going to be putting up the prices of energy shortly, and it's not just food that's going up. So all I'm saying is, you know, your wages are going to start shrinking as a result of this, guys. You have to pay attention to that. You know, all these things are spelling the same thing, and that is what's going to affect us all inevitably at some point down the road. And it's not going to be the distant future, it's going to be, you know, the near future. Food prices are going to go up, energy prices are going to go up, and we're going to have to start looking at alternative means to providing our own food short term and our own energy. And you know, I've looked into lots of things. I'm going to share something with you guys, and I've looked into a lot of different things like V-gate magnetic motors, Newman motors, you name it. I've built lots of these things, including hydrogen fuel cells, you know, where you use electrolysis to convert, you know, water into its fundamental atoms, oxygen and hydrogen. But the most efficient thing I found was induction coils. And I think that there's more research to have a look into that. And basically what I'm talking about, and it needs a lot of investigation, we're at early days, but it's the only thing that's shown promising results for me, and I'll share it with you guys. And that was basically winding more wires in a coil that only had one wire connected to the power supply. And what I found is that the frequency bled off into the other wires that was in that coil, and you was able to tap off the electricity. Now what I'd like to do, I've got the clamp meter we can put on there, so we find out how much is going into the coil to start with and how much is coming out the coil, and we can also measure the volts and current that's been drawn through the coil, through the main wire, and we can also measure the volts and current that's coming out the other wires within the coil. The point is this: if this is promising, what this means is that we can use one wire that comes into our house for the electricity, and we can probably make it more efficient. I'm not saying that we're going to get free energy out of it. I'm just saying that through being in the vicinity of the main wire, the frequency leaks out into the other wires, and therefore we can tap that electricity off as well. Now, I have done some simple experiments which shows that, you know, even though these wires are not connected and there's enamel coating separating them, we do get electricity bleeding off through the frequency, touching the other, you know, being in the vicinity of the other wires. So all I'm saying is that we might be able to reduce our energy costs probably by about threefold if after all the tests show that, you know, just by being in the vicinity of the first wire in the coil, there is energy to tap off that. You know, if I can do as much as I can for you guys, you know, I'm willing to do that, and I'm willing to share, you know, even these ideas with you. But, you know, as regards to magnetic motors, trust me, I have invested many hours, and I've replicated a lot of these devices that you see on the internet, you know, claiming to be perpetual motion, but they don't work. Simply what the problem is with magnets, as you'll find, is that one has a north pole, one has a south pole, and they're equally weighted. And I've tried bending the magnetic polarities of these to, you know, push the south pole away so that when the magnet comes back round the wheel, you know, it's not in the vicinity of the south pole, so it should just keep clicking over the north and being pushed away. But the other thing is that you've got a south pole on the other end of the magnet, and it just don't work, guys. You know, so as many of these ideas that claim to you know, generate free energy, there's just nothing there with regards to magnets. You know, we've got the use of wind power generation, hydropower generation. If you live by a river and you can tap the stream, you know, just put a hydro generator in there, or, you know, like the old-fashioned windmills that turn a generator or a series of gears and then a generator, then you can tap off, you know, relatively free energy from those sources. Or you've got solar panel energy. And one thing I just want to talk about solar panels, one thing that's always surprised me is, you know, we have sun shining on one side of this earth for 12 hours of the day, and then on the other side of the earth it shines the other side. Why we've never worked together on this planet and just piped the energy from one side that's got the power to the dark side of the earth, you know, and then swapped it over during the daylight on one side, tap it back over to the other. You know, why haven't we ever done that, guys? If solar panels don't work in darkness, as we know they don't, so why don't we just build solar panels and share the energy between two sides of this earth? I just don't know why we've never done that. Because at that rate, we wouldn't need batteries. We could just, I know there'd be a loss through the, you know, the transmitting of the electricity, but, you know, you'd still have power being sent to the other side of the world on the night time. I just don't know why we've never done it. But there you go, guys. You know, some things that are coming up at a later date, and like I say, you know, we don't just talk about things here, we actually do a little bit more than that. And I'm just going to mention the links down there. If you want to support us, you can, guys. We put a lot of effort and time into what we do, and, you know, we get the answers to these anomalies that you're not getting from these organisations. And at a time like now, it should encourage more people to support the Mavestar Observatory. So I'm just going to leave it here, you know, guys. You have an amazing day. The links are down there if you want to support what we do, and I'll say what I usually do. Bye for now.